Let's move on to the last part of our neuro-ophthalmology, everybody. The easiest part, the most fun part, everybody. That is color blindness. Now, as soon as I say color blindness, everybody, what do I mean to say? I mean to say that a patient cannot see colors. So the first question that comes into my mind is, what colors are we talking about? So we are talking here about our primary colors, guys. So how many primary colors are there? That's the first question. To understand the topic, we need to know this. So the colors are 3. What are the 3 primary colors? Yes? Yes, all of us know. But some of you are saying red, blue, green, green, blue, red. Some of you are saying in some order, some in other order. That is where the problem lies. That is where our problem starts. We need to remember these 3 colors in a particular order. And only then we are able to easily answer questions. So what is the order and how do I remember them, everybody? So we remember them as RGB. Red, green, blue. Okay, everybody? That is the order that we need to remember them in. Red, green, and blue. Okay? Now, how I remembered them? I remembered them through the name of a movie director, everybody. Bollywood, Tollywood, Collywood, all kinds of movies he makes, everybody. Ram Gopal Verma. I have just made him Burma. Okay. So that's how I remembered it. As soon as I heard RGB, that is what came into my mind. RGB. Okay. Ram Gopal Verma, red, green, blue. So that I never forget it. Now the question is, sir, this we could have remembered otherwise also. We are MBBS students, we remember so much. Why such a kind of a bakwas trick for such a simple thing? Because along with this, you need to remember that red is called as prota. Scientific, you can say, or medical, you can say. Green is called as deutera. And blue is called as trita. Okay, everybody? So that is what the examiners are trying to ask you when they are actually asking you the question. That do you remember what is prota, deutera, or trita? Now, how to remember this, everybody? Again, there is an English way and there is a Hindi way. And there is a Sanskrit way. So let's do with the Sanskrit way first, everybody. Okay? Sanskrit, a lot of our languages in India are based on Sanskrit, everybody. Okay? In Sanskrit, we have heard 3 words, everybody, I hope. Pratham. Pratham means first. First means prota. Dvityam. Dvityam means second. Second means deutera. And Trityam. Trityam means third. And third means trita. Am I clear to everybody? Or how do I remember it in Hindi, everybody? P for prota. P for pehla naam. D for deutera. D for दूसरा नाम. And T for trita, तीसरा नाम. Am I clear to everybody? Yes. So that is how I remember, everybody, prota, deutera, and trita. Either through Sanskrit, pratham, dvitiyam, tritiyam, I remember them, or pehla naam, dusra naam, tisra naam, Ram Gopal Verma, red, green, blue. I know there can be easier ways of remembering this, but this is how I remember, and I hope a lot of you use this to remember this. Okay. Now that we know we are talking about red, green, and blue color, let us dive into the classification of color blindness, everybody. So when we classify color blindness, we say color blindness is broadly of 2 types. First is acquired color blindness due to some cause after birth. Second is congenital. That means at birth. Okay. Now, let's first start with acquired color blindness. So what are the causes which lead to color blindness as part of acquired classification? Number 1, everybody, optic nerve diseases. All optic nerve diseases cause red-green color blindness. Okay, everybody? Any optic nerve disease, like we read in optic neuritis, everybody. Optic neuritis leads to color blindness, red-green. All optic nerve diseases can cause red-green color blindness. But the new question here is except everybody, glaucoma. Yes, glaucoma is an optic nerve disease. If you have read it, you know it already. If you haven't, then I'm telling you here, everybody. When we read glaucoma, we will read that glaucoma is a group of progressive characteristic optic neuropathies. Glaucoma at last is an optic nerve disease. I know the raised IOP part, but it is an optic nerve disease. So we are saying there are two questions which can be asked here. Optic nerve diseases cause which color blindness? Red, green. Which optic nerve disease does not cause red, green blindness? Glaucoma. Okay. Moving on, everybody. Number 2, macular diseases. Should not be any confusion. Macula means fovea. Fovea is the largest concentration of cones. Cones are responsible for color vision, everybody. Yes, so obviously there will be some color blindness. And usually we say it is blue, yellow color blindness. Again the question, except in an important disease which is called as Stargardt's disease, which has been explained in detail in the retina topic, everybody. Okay. And lastly, in old age, blue color blindness. Okay, everybody. So these are the 3 topics or the 3 points here and 5 questions here under acquired color blindness, which you can just rote learn and answer in a question. Nothing to explain here. Yes. Now we move on to congenital color blindness, everybody. So the second type of color blindness, congenital color blindness. As soon as I say the word congenital, everybody, the first question that comes into my mind is it inherited? If it is inherited, what is the most common mode of inheritance? Anybody? What is the most common mode of inheritance? Most common mode of inheritance is? Yes, X-linked recessive. And from here another question can be answered. If we know it is X-linked recessive, everybody, X-linked recessive condition occur more commonly in males or in females, everybody? Yes, more commonly in males. Females will be carriers. Yes, so we answer 2 questions through 1 point if we understand basic genetics. Also remember that the genes for red and green color are located on chromosome X, but the gene for blue color is located on chromosome number 7. Another question can be asked from here. I hope you understand. Yes, most common is X, and on X red and green are situated. So if I ask you blue color blindness is inherited X-linked recessive, true or false? Obviously it will be false. Blue color blindness will have to be autosomally inherited. Yes or no? Because the chromosome is number 7. I hope there is no confusion in this. Also based on these 2 points that the most common mode of inheritance is X-linked recessive and red and green are located on chromosome X, if I ask you most common color blindness, what will be the answer? Obviously the answer has to be red-green color blindness. 1 plus 1 is equal to 2. It's always been the same. It will always be the same, everybody. I hope there is no confusion in this. Okay. Now, further classifying congenital color blindness, we say types of congenital color blindness. What are the types of congenital color blindness? For that, we have a pre-made table for you here, everybody, that we will discuss. Types of congenital color blindness can be divided into 2. The first name is written dyschromatopsia. The second name is written achromatopsia. Fancy words with very small meaning. Let's compare these 2 words, dyschromatopsia and achromatopsia, to 2 words which we know. Dysgenesis and agenesis. Formation of an organ, let's say we are saying agenesis or we are saying dysgenesis. What are we trying to say? What is the difference between the 2 words? Agenesis means absolute non-formation. Achromatopsia, absolute no color vision. Chroma means color. A means absolute absence. So there is no color vision, absolute absence, total color vision blindness. Okay. Whereas if I focus on the word dyschroma, I know chroma means color, and I know dys means some kind of malformation, just like dysgenesis, malformation of an organ. So dyschromatopsia means that there is some color vision, but there is some problem in color vision. Am I clear to everybody? Some problem in color vision, dyschromatopsia. Now, focus on dyschromatopsia. Some problem. What problem, everybody? So dyschromatopsia is further divided into two parts. The first I am saying dichromatic. Again English everybody, dichromatic. The patient is saying I am dichroma. Chroma means color, di means two. So the patient is telling you that I can see how many colors? I can see two colors. But I am blind for one color. So the patient is color blind but not totally color blind. The patient, let's say, is saying I can see red and green but I cannot see blue. Okay everybody, so the patient is dichromatic. So perception of one color is absent. Patient is blind for one color. I hope you understand. Patient is blind for one color. I am writing here blind is equal to anopia. Okay. Now, the second dyschromatopsia patient is saying I am trichromatic. I am trichromatic. That means, sir, I can see all the three colors. But I have some anomaly. Anomaly means I have some defect. So I am writing defect is equal to anomaly. Meaning what everybody? The patient is saying, sir, I can see all three colors, but I have some defect. What do you mean by that? So let's say, assume a patient, the patient is saying, sir, I can see red, I can see green, I can see blue, but I cannot differentiate between red, orange and pink. So red, orange and pink are formed from red only, yes? If you mix red with yellow, you get orange. If you get red with blue, you get pink. So that means there is some problem in the red colored cones, everybody, that the patient is not able to differentiate with like colors. Okay? So the patient is saying, again, I can see three colors. I am trichromatic, but I have some defect in my color vision. That's all he's saying. So that is why he's become trichromatic anomalous. Now, based on these two words, everybody, which we have just mentioned, blindness of a color, I can call the patient is anopia for a color, or defect for a color. That means the patient has anomaly for a color. And the three names we have read just now, everybody, prota, deutera, trita. Questions are asked. What kind of questions are asked? Let's see. The examiner will ask you, what is protanopia? So when the examiner asks me what is protanopia, I make it into two parts. The first part is prota. The second part is anopia. Prota means which color? Pehla. Pehla means red color. Anopia means blindness. So my answer is red color blind. I need to learn to differentiate this from the second word that the examiner asks me. Prota anomaly. Again two words, listen to me. Prota anomaly. Prota means again which color everybody? Prota pehla, red color. Yes. And anomaly as we have written is defect everybody. So it becomes what everybody? Red color defect. So I hope you understand that each color can either have an anomaly or an anopia. So prota anomaly, prota anopia. So it is important to remember two parts now. The names of the colors and the difference between anopia and anomaly. Am I making myself very clear here, everybody? Yes. So based on this classification, we have 6 types of color blindness listed on the screen for you here. So these are the 6 types of color blindness. Out of these, the most common is deuteranomaly. So see, it's just a way of asking questions. Earlier I asked you what is the most common color blindness. We said red, green based on the chromosome part. Here I am again asking you what is the most common color blindness based on the 6 names or the 6 options that the examiner has given us. I am saying the answer is deuteranomaly. Yes. I hope the nomenclature does not make you dizzy. Dyschromatopsia, some problem. Dichromatic, 2 colors visible, 1 color blind. Blindness means anopia. And trichromatic anomaly means 3 color visibles, but some defect in 1 color. Defect means anomaly. That's your short revision. Okay. Moving on to the second arm now, the easier arm, everybody, achromatopsia. The patient is saying, I am absolutely colorblind. This is further divided into 2 parts, rod monochromat and cone monochromat, everybody. Let's first understand rod monochromat, easier to understand, everybody. Rod monochromat. The patient is saying, I have color which is single and that color is given to me by rod cells. Rod cells give us which color? Black or white. Basically, you understand night vision, everybody. So the patient says, I can only see black and white television. I can't see color television. He's still living in the 80s, guys. Yes, but he's suffering from a condition that is rod monochromat. Please remember that this is inherited autosomal recessively. Done? No confusion? Now we move on to the condition where you need a little bit of psychology to understand. Cone monochromat. Now what is the patient trying to tell me? The patient is saying, I have color which is single monochromat, which is given to me by a cone cell. I have single color. That means either my R, my G or my B is functional. So let's say my R is functional. So I am coming to you and saying, sir, I can see red color. But still I am trying to tell you that I am achromatopsia. Why, sir? Color makes sense because we have color opponent theory. That means color makes sense because something is green, something is blue, something is red, something is yellow. Yes. So there is difference between colors. That is why colors have sense. If everything is a shade of red to me, I am as good as colorblind because I cannot see color. I hope you understand what I'm saying. That's where the psychology sets in. Okay. So only one color perception is present, but because there is no differentiation of colors, it gets classified as achromatopsia. Am I clear to everybody? That is your simple classification of the types of congenital color blindness, and this is your two types of color blindness, that is acquired, which we have read earlier, and now congenital. Whatever the types of color blindness may be, we need to do some tests, everybody, which we have. I know we have. I know. Yes, all of us have at least done Ishihara chart. Why we have done Ishihara chart? Because this is the most common test. In our postings, we must have somehow made our friends color blind by hook or by crook, everybody, when we had done Ishihara chart test. Yes. So even though it is the most common test, everybody, but still I say it has a limitation. The limitation is it cannot detect Triton defects. So if a patient is suffering any problem with blue color, everybody, Ishihara chart is not the one to go for. So that means it is the most common test, but not the most sensitive or the best test. So the question which should come into mind, if Ishihara is not the most sensitive test, then what is the most sensitive test? The answer is Farnsworth-Munsell 100 hue test. This is the most sensitive test. Okay, everybody. So two simple questions about two simple tests. Then, what is Hardy-Rand-Ritter test? Hardy-Rand-Ritter test is used in pediatric population. Okay, everybody, pediatric use. Then Nagel's anomaloscope is used to ascertain the severity of loss. A person may be having 10% defect, another may be having 60% defect. So to understand the severity, the percentage of color vision loss, everybody, that is where we do Nagel's anomaloscope. Farnsworth-Munsell 15 hue test. This is used to differentiate between congenital and acquired. So if we want to know that whether the patient has a congenital colorblind or an acquired colorblind, the most useful test is Farnsworth-Munsell 15 hue test. And lantern test is for vocational testing. Vocational testing basically means, or vocational jobs, if we have heard ever advertisements, vocational jobs means jobs which do not require formal education. Okay, so in the 1920s, 1930s, everybody, that kind of era, railway driving did not require you to be a 12th pass or whatever. It was a vocational job, everybody, because you were basically wanted to be able to see 2 or 3 colors, that is red and green. Manual crossings, yes. If somebody was standing with a red colored cloth, that means the train had to stop. If somebody was standing with a green colored cloth, that means the rail could pass, everybody. Yes. So there it was invented the test lantern test, everybody. A red color or a green color, whether you can see those colors, everybody. Am I absolutely clear about these tests? I hope there is no confusion in this. Okay. The names and simple points. Now what becomes important is whether you are able to identify these tests, everybody. So let me show you a photograph and let me ask you if you know this test. What is this test, everybody? All of us have done this. All of us know this. Yes. See this chart? See this chart? Yes, I know this. A lot of you are saying this is Ishihara, but a lot of you are wrong. If you have ever seen Ishihara, you have seen that Ishihara consists of numbers or irregular shapes. But in this chart, we see a red colored O and a red colored X. If we see the key on the page, everybody, there can be either a circle, a triangle, or an X. This is my Hardy-Rand-Ritter test. This looks same as Ishihara, but it is not Ishihara. This is inducing the false positive out of you. Yes or no? Then let's see this image. What is this now, everybody? Yes, now you can confidently say, sir, this is Ishihara chart. Yes, sir, this is Ishihara chart. We know we can see all kinds of irregular shapes, or we can read numbers like 42 here, 2 here, 45, 74, 97, 6 and 3, everybody. You're not doing your test, just saying it like that. Okay, everybody? Now, both these tests are similar in terms of the property they use to be able to make out the color vision, whether it is normal or abnormal. So we call both of these as pseudo isochromatic charts. Okay, so both these charts are based on the same principle, pseudo isochromaticity, pseudo isochromatic charts. Okay, now if you are smart enough, everybody, when I show you the next photograph, I hope you will be able to find out or tell me which test is this. Just see this photograph. I know you have not seen this test before, but use your common sense. Use that list, everybody. Use that list. Try to tell me which test it can be. Which test can it be? Yes, Farnsworth-Munsell 100 hue test. I see some buttons, some caps of colors, everybody. Without counting, I can say they must be like 50, 100, everything, something like that, everybody. Yes. So the most likely answer out of the test becomes FM 100 hue test. What am I trying to tell you here, everybody? You may forget a photograph, but if you remember the theory, everybody, you can link that theory to the photograph. As a saying goes, everybody, you know what you have read and you see what you know. So you have to first read, then know, and then see in an image. You can't jump this chain, everybody, please. Okay. Similarly, if I show you this photograph now and ask you what is this test, everybody, I know I can see around 10-15 colors here, so that must be my FM15 hue test. No confusion whatsoever. Yes or no, guys? Done. And that's all about the short and sweet and simple topic, everybody. Color blindness questions usually get asked from this topic, albeit simple. So if you just read it once or twice, you focus yourself, you should be able to do it with this. That's all about color blindness, and that's all about our mammoth topic, neuro-ophthalmology. And I hope I have been able to take that dagger out of neuro and put a heart in that. I hope you love neuro-ophthalmology from now on. I love it. I love to teach it. And I will again reiterate, if you read it once with your open mind, if you try to understand the concept, you never forget it. And that's the beauty, everybody. Neuro-ophthalmology, done. That's what you should be able to say post these videos.